Welcome students. Today we'll learn about Gauss law. Before that, need to know what is area vector. Suppose this is an area. I will take a small section ds and this is the direction perpendicular to the area, that is n cap. So area vector will be the magnitude of that area into direction. So n cap represent direction into ds. ds is in magnitude. I think you will be in trouble. Suppose this is my area. What is area vector? Now look it. This is area vector. This is magnitude and this is the direction. Direction is n cap. Always perpendicular, normal to the surface. Is it clear? This is a vector quantity. Now electric flux. What is electric flux actually? Just think that these are my electric field. Suppose within a particular area, how many electric lines of forces are there? That represents flux, electric flux. Is it clear? Suppose for this case I got 2, 3, 4. So 4 is my flux. Clear? Let us go for mathematical point of view. So let these are electric field. Now look it here carefully. This is my area. Think like this, and this is my area vector. So to that area vector and electric field, angle is theta. So it has two components. What are the two components? Check it. One is along the direction of electric field. Another one is perpendicular to the direction of electric field. Now, for this case, if I will check it properly, now what will I tell? What is electric flux? Flux is in scalar quantity. It is nothing but the product of area vector and electric field and the lines of force which are perpendicular to area. That things we have to consider here. So through an area is defined as product of electric field strength and area perpendicular to the electric field. Those things consider. Now area perpendicular to the electric field is nothing but d cos phi or cos theta. That's why flux is considered E ds cos theta. Just to remind, for the time being, phi is nothing but dot product of electric field and area vector. Let me tell you again, phi is nothing but electric field, dot product of electric field and area vector. Now, for integration parts I can write, if I'll take small section ds, if I'll take for total I have to take integration, so E dot ds. If I will take for a closed surface like a sphere, this is for open surface case. If I will take for closed surface, the electric flux will become E dot ds. This is for closed surface. Now you can find out its unit. This is for Newton per coulomb. This is for meter square. So what will be final? Kg meter per second square. This is Q equal to IT ampere into second into meter square. So what is the dimensions? I am getting kg for m1, L3, t minus 3, a to the power minus 1. Now, how to read these things? Let us read it once. This is surface integral. Integration dot ds is surface integral of electric field around a closed surface. Is it clear? Now the question is Gauss law. What is Gauss law? It states that total electric flows passing through a closed surface is equal to 1 by epsilon naught times the net charge enclosed by the closed surface. From the first point, it is very difficult to get the point. For me also same thing happened. How to remind it? Very simple thing. Flux equal to Q by epsilon naught. How to know it in mathematical point of view? Let us consider this is a sphere. Obviously closed surface like a football. What are the charges are there? Suppose Q1, Q2, Q3. The net charge is Q. If it is plus, flux is outward. If it is minus, flux is inward. Because plus means electric field is outward. Minus means electric field is inward. Now the question is, if this is my flux, so my charge, suppose these are positive charges, these are my direction of electric field, then the net flux is Q by epsilon naught. Now mathematically how can I represent it? Let us write down here. What will I write? This is flux. What is flux actually? Surface integral of electric field is flux, and this is a football type sphere, means closed surface. So is it cover? That means from equation 1 and equation 2 I can write flux is nothing but surface integral of electric field. This is surface integral dot product is there of electric field around a closed surface is nothing but net charge enclosed by that surface by epsilon naught. Let us check it again. How can I read this? Surface integral of electric field around a closed surface is Q by epsilon naught. Let me tell you some concept. If charge is plus, flux will be considered plus. If charge is minus, flux will be considered minus. If it is moving outward, it will be plus. If it is moving inward, it will be minus. Let us solve some problems. Suppose this is my closed surface. Here is 5 coulomb minus 3 coulomb. What is the total flux? In this case, 5 minus 3, I will write total charge is 5 minus 3 by epsilon naught. That is equal to 2 by epsilon naught. You got my answer? Suppose, second case, there is 5 coulomb minus 3 coulomb. Here 2 coulomb is there. So what is the net charge? Net charge will be 5 coulomb minus 3 coulomb. It will not be considered. So it will be 2 coulomb. So flux will be equal to 2 by epsilon naught. Is it clear? So if charge is outside, it doesn't matter. We have to consider only inside. Okay. Now the question is, if charge is outside, net charge is 0 inside, flux will be 0. Charge is outside, electric field inside the sphere exists or not? If exists, why flux is 0? Think it. Now we will go for the proof of Gauss law. We need to prove it. I don't know how to prove it. Let us start. So from here famous 2 marks or 3 mark questions can be asked. Listen those questions. Derive Gauss law or proof of Gauss law. So what I am writing here, proof of Gauss law. How can I prove? I am using hand, but you should not use hand. Better to use rounder. So how can I prove this Gauss law? By the help of Coulomb's law. Reverse is also there. Derive Coulomb's law from Gauss law also there. You need to derive it. Just reverse procedure. Let us consider a sphere. Sphere is completely like football. Now what I want, let us take small elementary area. Let us take, this is the small elementary area. This is the center. Center is O. Now what I want to do, draw this line. This process again we will repeat in Gauss law applications in next class. For the time being, just focus to this thing. So this is my radius R. So obviously this is radius vector. This is nothing but elementary area ds. So this is my ds vector. What I want to know, let here the charge is capital Q. Let here test charge is small q naught is there. Separate by a distance r. This is plus. Plus plus means repulsive. So this is my electric force. So let us finish it quickly. So what is the electric field intensity at this point, or what are the telling force also you can take? What is the force actually? K Q by R square. What is the electric field? Of course it has direction. Let this is O, this point is P. I will write this is along OP. F by Q, force by test charge. So force is Q by R square into 1 by Q. So I got KQ by R square. Now this is my electric field. In vector form, it is also along OP direction. Now what do you need to know? Flux. What is flux formula? Surface integral of E dot ds along the closed surface. So what is ds vector and electric field? This is also electric field. First direction is electric field. So between them angle is 0 degree. So let us write down. So flux equal to E ds. If I remove the dot product, cos 0 is nothing but 1 around closed surface. Force is nothing but KQ by R square into ds. KQ R all are constant, will move to outside. So remaining is closed surface integral of that part. K value is 1 by 4 pi epsilon naught Q by R square. Surface integral, integration of ds means surface integral of sphere is 4 pi R square. This is nothing but 4 pi R square. So what is cancelled? 4 pi R square. 4 pi R square. Remaining part is Q by epsilon naught. So flux we got Q by epsilon naught. Now the next task is from reverse. How can you get Coulomb's law? It is your task. Check, solve, and try to solve some problems. Thank you.